Hi, in this video we're going to do some more homework from lesson 5.3, and we're going to do number 42, we're going to do number 74, and we're going to do number 84. So if you need to fast forward, go ahead and do that now. Let's read the directions for number 42. It says, evaluate each expression. Do not use a calculator. Okay, let's not try to type this in the calculator, and let's see if we get the answer right. First of all, to let you know that this is called natural log. Natural log, in this case, just means whenever you see it, it has a base of e. So I'm going to rewrite this problem with the base that's not shown. It's not shown in the problem. This is natural log. This is the ln part right here. There is a little e that's hidden. It's not shown. It's its base. It comes below the word log. And then you have the argument, which is even with the base, so with the log, with the natural log, and it's e to the square root of 6. You have a rule that says, and I'm going to circle this, you have a rule that says that if the base matches, if the base of the log matches the base of the argument, okay, this e is part of the argument, this e is the base of the log. So therefore, if these bases match, the only thing left is your actual exponent on your argument, which is the square root of 6. And that problem is complete. Okay, so that's one of your rules. It says if your bases match, then your exponent is your answer to the question. And that's complete. We're going to go on to number 74. Number 74 says, use the properties of logarithms to rewrite each logarithm if possible. Assume that all variables represent positive real numbers. Alright, since you can't take the logarithm of negative numbers, they make that little statement, assume that all variables represent positive real numbers. That way we can work all this out. So it's really just a technicality on saying that they're positive. The real work comes in knowing all your properties of logarithms. When do you write a plus sign? When do you write a subtraction sign? When do you multiply? You know, these are all the things that we're going to be doing in this particular question. So first of all, I see a couple things that I would like to do. The big one is this big division bar right here. When you have a logarithm and your argument, and this is all the argument right here, the argument is separated with a division, you can use the properties of logarithms that say I can change that back into subtraction. So I am going to do that. So I'm going to say log base 2. Notice it is a base 2. It's going to be base 2 on every log that we have on here. Okay, log base 2 of 2 square root of 3. Now one thing I do notice right away is a square root of 3 can be rewritten. I'm going to rewrite that as 3 to the 1/2 power, because it's a square root and it's 3 to the first power. This is 3 to the 1/2 power. Now I still haven't done my minus sign yet. Here's my minus, because I have to take this division bar and change it in subtraction. When you do that, you don't just write 5p. You actually have another log, and it's log base 2 again, but this time you can write the 5p, which means 5 times p. Okay, we also have, now we have 2 logarithms. Back at the beginning we had 1. Now we have 2 logarithms. This first logarithm has an argument that has a multiplication in it. And that means we can change that, we can separate that by using a plus sign. So I'm going to go ahead and rewrite this as log base 2 of 2, that's this first one, plus, and when you write it plus, just like last time, you got to put another log in there. And this time it's going to be the log of 3 to the 1/2 power. Now the second one, here's this minus sign right here. You have a multiplication going on. We're going to use a plus sign. But remember, it's log of all of this, which means I'm going to use a parenthesis now because I'm subtracting. Everything I write afterwards has to be minus. And I'm going to change multiplication into a plus just like I did on the first one. So I'm going to have log base 2 of 5 plus log base 2 of p. And I'm going to close it. And again, I use parentheses because it's following a minus sign up here. All right, let's see what a couple things we can do. Let me change color here to show you one thing. You see this 1/2 right here? You have your power property, which says I can move this 1/2 out to the front on the next step. I can just pull an exponent out to the front. It's the only, there's no multiplication like there was right up here anymore. Okay, I can just pull that 1/2 out to the front, and I won't have any exponent anymore except for a 1. 3 to the first power will be left. I'm going to take this minus sign right here on the next step, and I am going to distribute it through. And really, the big thing is it's going to change this plus sign right here to a minus sign. And the other thing is, using what we did on the previous example, just to bump it back and show you real quick, if the bases match, the exponent is the answer to the question. Well, here you have two bases that match, and this 2 has an exponent of 1. So the answer to this problem right here is 1. This very first log, the answer is 1. So let's rewrite this now, okay? I'll change it back to red. We're going to say it's equal to 1. All of that is the answer 1. That's all that's left of that log. Plus, the 1/2 is coming out to the front. Log base 2 of 3 minus, distributes. So we got minus log base 2 of 5. Oops. And minus log base 2 of p. I'm going to look at it one more time. I don't have any work to do with number 1. This has the log just has really a base, an exponent of 1. That's good. Leave it when it says use the property of logarithms to separate it all out. That's good. This one again has a base with an exponent of 1. Nothing else to do. This one has a p as its base with an exponent of 1. Nothing else to do. So this problem is complete, and I'll go ahead and box it. And that problem is done. So that means that we are on to problem number 84. Now problem 84, directions say, use the properties of logarithms to rewrite each expression as a single logarithm. Assume that all variables represent positive real numbers again. Okay, so we're doing exactly opposite of the last problem. We're taking these logarithms and all these items, we're putting it back together as one log. Simplified as much as possible. We're putting it together as one log. So let's see what we can do here. First of all, this 1/2, since it's multiplying, I can put it back up as an exponent on technically both of these, so we're going to use parentheses to show that. We're going to put that 1/2 back as an exponent. We're going to take this 2/3 and we're going to do the same thing, and we're going to use parentheses around here to show that. So here's what we have. We have log base y of p to the 3rd, q to the 4th, and all of that is being raised to the 1/2 power. Minus, we have log base y of p to the 4th, p to the 3rd, and actually I'm sorry, I have to back that up for just a second because I didn't notice that looked a little weird. This right here is not a p, this is a q. So I have to make sure I fill that in over here. This is q to the 3rd power. I apologize about that. And I was like, well, wait a minute, p and p, we can put those together and say p to the 7th. But looking back in the book, this is a q to the 3rd power here. I'm going to pull this 2/3 back up as the exponent. All right, I'm going to say equals. Since 1/2 is covering both of these, you have to multiply 1/2 times 3 and 1/2 times 4, and the same thing over here, 4 times 2/3 and 2/3 times 3. So let's see what these new numbers are. So essentially we're getting rid of parentheses here. So we got log of p to the 3/2 power. We have q to the 4 times 1/2, which is 2, minus log base y. I got to put my y back over here also. Log base y of 4 times 2/3. Well, 4 times 2 is 8, so that's 8/3. So p to the 8/3 power. And we have q to the 3 times 2 is 6. 6 divided by 3 is 2. Q to the second power. When you have a subtraction between logs, we can put that back together as division. So that means you have 1 log now. It goes from 2 logs back to 1 log, and that's all we have left. But you have p to the 3s power, q to the second power, all over p to the 8/3, and q to the second. Essentially, we put it back together as 1 log, but you just have to make sure that your argument is all simplified down. And I see some p's that are bases that can be put together, and also some q's. So first of all, let me go ahead and get this little blue out of here, because I see that these guys up and down, they cancel. Q to the second, they're gone. But that's not true of the p's. The p's, you have to follow your exponent rules. And the exponent rules say, and you don't have to write this, but you have to do this. You have p to the 3/2 minus 8/3. You have to subtract your exponents when the bases are being divided. So let's see, what do we have? Log base y of p to the, now just to show you, you know, a calculator can do this, but you're getting common denominators, and the common denominator between 2 and 3 is 6. So if I multiply this 2 by 3, I get 6, but I have to multiply this 3 by 3. So that means this is 9/6 minus, to change this 3 into a 6, I have to multiply by 2, so I have to multiply the 8 by 2, so that makes 16/6. And that means you are left with log base y of p raised to the 5, I'm sorry, that's a 9, can't even read my own writing. 9 minus 16, which is -7 over 6. And just to make it look a little bit prettier, we're going to pull this negative. This is a really like that power log, how we took the 2/3 and we put it back on top. We're going to take that and we're going to put it back down on the bottom. So I'm going to take this negative and I'm going to move it out here just to make it look a little prettier. This is one of those steps where it's like in question whether or not you really have to do it or not, but it really makes it look prettier at the end. You're just negative log base y of p raised to the, instead of -7/6, it's going to be +7/6 power. And everything is together, completed in 1 log. Everything looks pretty. If you look back up here, this looks like a lot messier than what you have down here. And this problem is complete. And that completes this video of lesson 5.3.